Okay, I'll send you the link in a second, Giovanna. Okay, I'll send you the link in a second, Giovanna.
Okay, I think we're good to go. Ayana, take it away.
Certainly. Well, hello and welcome everyone to the Hope, Empower, and Rise or Her Path Seeds of Success webinar series. I am your host, Ayana Doss. I'm a PhD candidate in biomedical engineering here at Yale, and I'm also a fellow working for Seeds of Success this year. So, what is Seeds of Success? Well, Seeds of Success is our out of school program to familiarize 6th to 8th grade girls in the greater New Haven area on careers that are in science, technology, engineering, medicine, and mathematics, or more commonly known as STEM. We do this by exposing our girls to female scientist role models, getting them engaged in fun STEM workshops and activities, and also allowing them to get creative in a place-based STEM community outreach and leadership projects. We do this to tackle gender stereotypes that are unfortunately very common in STEM, and we hope to promote STEM access at an age where students are beginning to kind of internalize those social stereotypes. And so we kind of want to reverse that and let them know that they can also do STEM as well. We have an amazing team here for Seeds of Success here, starting with Giovanna, who is our director and PI for the program of Seeds of Success. Carolina, who is our program manager as well for here at Seeds of Success. They both do a wonderful job. And helping to support them to make all of this available to all of you is our GPE fellows of UNITSA, who I don't think is here at the moment, but Ayana, me, myself, and Leslie here to help all of this whole program come to fruition. And we thought it would be a little fun for you guys to all see all of our team pictures, but when we were all teenagers, which is kind of cute here. So you can see every single person who makes up the team, kind of who we were when we were about 16, 17, kind of just living out our lives. And you can see that we're just like you, cute, fantastical, having fun, and we all grew up to be incredible women in the field of STEM. I am so excited to have you guys all here and to hear from our very special guests today. But before we start, I do want to let you guys know we are welcome to actually ask questions once we hear from our guests. Feel free to put any and all questions in the chat below, or you're welcome to ask the question yourself as well. We just ask that you keep your camera off, but you can do this in our Q&A session at the end. So without further ado, I ask all of you to please welcome Dr. Cristina Rodriguez, who is here today to tell us about her personal journey in higher education and the world of STEM. Dr. Rodriguez is an associate professor in biomedical engineering here at Yale, and she has a passion for optics, which is integrating the light shape technologies and microscopy advantages in the lab to kind of explore the central nervous system while pushing the boundaries of imaging depth, resolution, and speed. I ask all of you to give a good round of applause. Dr. Rodriguez, welcome and thank you for being here today.
Thank you so much, Ayana. This is very exciting. Let me... Can you see my screen? Wonderful. Thank you so much. Good afternoon, everyone, and thank you for such a kind introduction. I am really excited to be part of this program. So my name is Cristina Rodriguez. I am a professor in the Department of Biomedical Engineering at Yale University. I started, 2 years ago, and I love science. Especially, I love working with instruments that let us see things that are invisible to our naked eye. And I started my journey in science actually in astronomy using these special types of telescopes, like the ones I'm showing in this picture, to study galaxies that are far, far away. Now I build instruments to look deep inside of the brain to help us understand how it works. So here is an image. So this is a diagram of a brain cell. It's called a neuron. These cells control what we think, how we feel, how we move. And this is an image of these structures that I took inside of a living brain with a microscope that I built. So today I would like to share a little bit about my journey in science with you. So I am originally from Venezuela, a beautiful country in South America. Have anyone, yes, have anyone heard about the Angel Falls? So it is the tallest waterfall in the world, and it is one of my favorite places. Venezuela is also full of incredible landscapes. So we have stunning Caribbean beaches, we have mountains, and we have so much natural beauty. Spanish is also my first language. So I grew up speaking Spanish at home. I still do. I'm also the youngest of 3 siblings. So this is Carolina, and this is Adolfo, and that's, of course, me. And I am now a mom myself. So I have 2 boys. So this is Diego, this is Emil, and then this is my husband, and this is my mom, who we, of course, lovingly call Abuela. Okay, so when I was your age, I went to a school called Institutos Educacionales Asociados in Caracas, which is the capital of Venezuela. And even back then, I loved math. So I still remember all of my science teachers because they were amazing and they made learning so exciting. And so that's me when I was about your age. Now, when I entered high school, I started taking physics classes, and that's when I fell in love with physics. Now, graduating from high school was very exciting, so I decided to go to college to study physics. I was really lucky because I got to go on this journey with my very best friend, who you see on this picture next to me. Her name is Yara Jaffe, and he's currently a professor in physics, and she's a wonderful astronomer. So you can see her in this picture, standing with all of these super cool telescopes behind. So this is in an observatory where she used to work in Chile. And so it's women like Yara and me, we became scientists because we were curious, because we were determined, and we had great mentors that supported us along the way. So the world, of course, needs more scientists with different perspectives and ideas, and that is why it's so exciting to see more girls like you who are excited about science and excited to explore science. So before we get to my college years, let me tell you a little bit about what's physics. Why did I get excited about physics? So when I was your age, I was very curious. I always wanted to understand why things happen the way they did. And physics help us answer those questions. So it is essentially the study of the world around us. How things move, for example, how planets move around the sun, why the sky is blue, how galaxies form, how rockets fly, and even how our brains work. So physicists ask big questions. And to do all of these, we use math and we do experiments. And of course, we have fun along the way. And curiosity, creativity, and problem solving are the skills that really matter the most. Okay, so then I went to college. I went to college in Venezuela at the Universidad Simón Bolívar, also in the capital city, and I absolutely loved it. So it was really exciting to dive deeper into the subjects that I was always fascinated by, like gravity and light and basically everything around us. So there was so much to explore. One of the fun things that we did to get younger students excited about science and about physics was that we did these physics demonstrations, just like the ones I'm showing in this picture. And it was just one way to share our excitement about science with other students and also show them how physics also applies to every day. And then that's me in one of my classrooms with, here you can see my best friend again and all of my classmates. Now, besides physics, I also had plenty of other interests. I've always loved the outdoors and I like sports and I still do. So during those years, one of my favorite ways to take a break from studying was playing soccer. So that's me and all of my wonderful soccer mates. So it was something that I truly enjoyed and it was a great way to stay active and have fun. Now, during my last year of college, I had a great opportunity to participate in a study abroad program at the University of New Mexico in Albuquerque. So I came to the US for a year, and that is actually where I took my first astronomy classes, and I completely fell in love with it. This is also where I got to do research for the first time. It was my first research opportunity with an amazing professor who was studying galaxies using these very cool-looking telescopes. And so we use data taken from instruments like the one I'm showing here, and these are called radio telescopes, and they look just like an antenna because that's what they are. And these help scientists look deep inside of galaxies that are far, far away. And studying these observations gave us clues about how galaxies form and how they change over time. So it was a really exciting experience because it was a way to apply all of the skills that I had learned, skills in math and everything that I learned during college, to a question or a set of questions that no one had necessarily asked before. So it was pushing the boundaries of what we knew. And it also made me realize how much I enjoyed research. So after my study abroad program, I returned to Venezuela and I graduated from college, and that was a huge milestone. But I love doing research, so I didn't want to stop there. So I like that idea of using math and physics to solve interesting problems and again, answer questions that no one had asked before. So I wanted to keep going, and I decided to continue my education by getting a doctorate, which is essentially what you do if you want to continue doing research. So I went back to the University of New Mexico to get my doctorate in physics. But this time, I decided to study microscopy. So I was still fascinated by the idea of making the invisible visible, just like in astronomy, but now I was using physics to build microscopes instead of working with telescopes. So I learned those skills, and I worked with exciting technologies, and I deepened my understanding of physics. Now, I will do a quick intermission. We'll take a quick break from the science. So just like in college, I had a number of different hobbies outside of my passion for science, which helped me stay balanced and take some breaks from the lab. So as I mentioned, I love the outdoors. I was an avid rock climber. So that's me on top of this cool formation in Utah. So when I wasn't in the lab, I was climbing mountains. I'm a Latina, so I love Latin music, and so much that I play percussion myself. So for a time, I played in an all-women percussion ensemble, which was really, really fun. And it was a way to bring my culture with me, right, and share it with others, which was really important while being so far away from home. Okay, so back to science. So I used my physics and engineering skills to then build these microscopes that allowed us to study the microscopic world, right? So, and at first I was applying these to study new materials. So I was looking at tiny structures in materials, and that allowed us to learn about special properties that these materials had. But at some point, I started wondering, could I use these skills to study the brain? Because I got fascinated about the brain in the same way that I was fascinated about the universe. And that's exactly what I did. So my next step, so I continued doing research, but now my work focuses on building microscopes that allow us to see deep inside of the brain, deep inside of the living brain, inside of areas and brain regions that traditional tools cannot reach. So this image here shows brain cells deep inside of a living brain. So each one of those blobs are neurons. Now, what's even more amazing is that we can also do experiments where we see in real time how these neurons, so these are the brain cells, how they fire. So every time you see one of those flashing, that means that these cells are communicating with each other and sending information. So with these advanced instruments, we can explore how brain cells work, so we can understand how they communicate. And what's really nice, right, is that if we can study and understand how the brain works, we can also start understanding what happens when the brain doesn't function as it should. For example, what happens in certain diseases like Alzheimer's, or even what happens when you have certain injuries like spinal cord injuries. Okay, so here I'll show you some images of my lab, along with examples of the different optical components that we use. So this is how our microscope looks. So it doesn't look like your traditional microscope. So we use different types of optical components that allow us to shape the light that we use to illuminate our samples in different ways. And that makes our microscopes really powerful. These photos also highlight the amazing scientists who make our research possible. So science is not something that you do alone. It is a team effort. So in my lab, we work together to solve problems and to push the limits of what we can see and understand. The scientists in my lab come from diverse backgrounds, and they have a wide range of interests. Some are physicists, some are engineers, others are biologists. They also come from different parts of the world, and they all bring their unique perspectives that make our research even stronger. So the world needs more scientists. More importantly, the world needs more women in science. So if you're curious, and if you love asking questions, and if you love solving problems, then science needs you. So I wanted to end by sharing a few important things with you. So looking back, it might seem like my path was straightforward, and that I knew what I wanted to do from the beginning. That was not the case. I didn't know what I wanted to do, and it was full of challenges. So what are some of the challenges that I faced? So in physics, I never had a female professor in college, so it was really hard to imagine myself in the field without role models. Hopefully that is something that is changing. But I will say that something that really helped is that I was lucky to be on this journey with my best friend. So that was really helpful. I think another challenge was this question of how to balance science and a family in the future. And so could I do both? Luckily, the answer is yes. And then, I was an immigrant when I came, of course, to the US to pursue my doctorate. So I had to learn to adapt and be flexible. And as I mentioned, it was very important for me to always, bring my culture with me. So I gave you this drumming example, which was really helpful. What else helped along the way? Of course, the support of my family, who always encouraged me. My mom, who I'm also showing here, she was always so supportive. Ever since I was in college, every time I had a major exam, she would make a huge arepa for me so that I would be ready for the day. So the guidance of my professors, of course, and mentors who believed in me. And I will say that also my love for mountaineering, just to bring back the importance of also having other things outside of your science life. I think that for me, it really taught me resilience, how to push forward even when the climb is steep. And I think an analogy that I really like is sometimes I would go out and I would be like, okay, I'm going to climb this mountain, this very cool mountain in Colorado. But from far away, it looks so steep, right? You can't imagine you could go up to that summit because it looks basically vertical. But as you start getting closer, you realize that actually there is a path and you can walk on that path. You just have to get a little bit closer so that you can realize that there is indeed a path. The other thing is that if you've been out in the woods hiking, I don't know if you've seen these like towers of rocks. They're called cairns, and they help you guide the way because sometimes there isn't a clear path, and they indicate where you should go. Maybe here you should turn right or you should turn left. And so for me, I see the mentors that I've had during my career as basically as Karen. Sometimes when the path is not clear, there's always been someone there who's been encouraging and who's shown me, okay, this time you have to go right, this time you should go left, or they've helped me come up with those decisions. So I never had a set plan for what I would do next, but I always followed my passion. This path evolved over time, and opportunities came up, and I took advantage as they happened. And the most important thing is to stay true to yourself, believe in who you are, and hold on to your values. And we just have to echar pa'lante, right? We have to keep moving forward. So I would like to first thank all of my lab members who make our work possible, and all of the agencies that support our work. And a big thank you for all of you for your attention and for giving me this wonderful opportunity to share my journey with you. And I would love to take questions.
Awesome. Thank you so much, Dr. Rodriguez, for that lovely talk you gave us. That was an amazing story. And now, anyone want to put their questions in the chat? Any questions you might have for Dr. Rodriguez about her research, about her journey, or just higher education in general, or just anything you kind of want to ask her, please put it in the chat. And if you want to ask your question personally, you can turn off your microphone and ask it. Just please keep your camera off. And of course, please give another person a chance to ask more questions. And we'll see how this goes. So please, who wants to be our first question? All right, first question in the chat. So, what does Dr. Rodriguez do for a living?
Great question. So I'm a professor in biomedical engineering. So my work involves a few different things. So I teach different classes on biomedical engineering. I also teach classes that are related to the work that I do. So about optics and how microscopes work, how light interacts with tissues, with matter. And then there's a research component. So I run a lab. So I show you a few pictures of the lab that I work, and I work with students, and I work with researchers, and we think of what are the new instruments that we want to build, and how do we want to show the power of these instruments. So those are some of the main two components of my job: the teaching and the research. So how often do I teach classes? So typically twice a week. So we usually teach one class per semester, and that meets a couple times a week.
I have a question from YouTube. During high school and college, Cristina, how were you able to balance school life, work life, and lifestyle?
Great question. And this is why I wanted to show you a few examples of the other things that I did besides schoolwork. I think it's important so time management, it's important, right? Try to do your assignments with maybe like not last minute, whenever possible. Sometimes you can't, but a good amount of time management. But it's important. It's important to take a break, right? Because it is when you take a break that you can then reset your brain and then look at the problems in front of you with a fresh brain. So I think that's really important. And then you stay active, you stay healthy, so that also improves your thinking. But it is possible. Just a little bit of planning and organization, and you can do it.
So we have another question on Zoom here. Who inspired you, Cristina?
Wow, who inspired me? I think I had a lot of people along the way who inspired me. Honestly, starting with my best friend. She was the one who, like, her curiosity about the universe was simply contagious. So that is how I got interested into it, and then that's how I got interested into physics. So that's one example. I had teachers who were very inspiring. I still remember one of my math teachers from high school. Her name was Luz. I mean, what a perfect name. That's light. Like, she was the most enlightened person, and everyone loved math with her. And as I kept moving in my career, I think I always encountered mentors that were a huge source of inspiration.
I have another question from YouTube. What made you switch from astronomy to brain science?
Ooh, yeah. So astronomy was fascinating. I really wanted to be more in touch with the instrument, and I wanted to be able to, on an everyday basis, tinker with instruments. And I think that you can do that as someone who works in astronomy. Most of the time, you're not necessarily working on the actual telescope, unless you're one of the engineers who's, working on these telescopes, but it works a little bit different. So then usually you reserve time on these telescopes, and then you get the data, and then you work with the data, and it's fascinating. But I wanted to be more in touch with the instrument. I wanted to build the instruments myself. And so that's how I then switched to microscopy. And then I had the opportunity to do that, to build new instruments and then make observations right there, right away. And then the brain is also fascinating. I feel like studying the universe, it's two very different things, but ultimately they're all about where we come from, right? In some way, in our origin. So I decided to switch to the brain. I saw a question that was, what has been the coolest thing you have seen through a telescope? So when I had that research experience during my study abroad program, we were looking at this pair of supermassive black holes that were in the center of a galaxy. So most galaxies have a black hole at their center. This galaxy had two black holes, and that was really cool because it is still the system with the closest pair of black holes that has been observed. And this is really cool from a perspective of galaxy evolution, because it is believed that, galaxies merge, and when they merge, the black holes merge. So it's kind of like you're seeing this system sort of not right before they merge, but in a sense. So that was really cool.
We got a
That sounds
question.
amazing.
It
I
does
have
seem
another,
pretty cool.
yeah. I have another question from somebody here in Zoom. How long have you been working on what you're working right now?
So in the type of research that I'm doing now, about 8 years. About 8 years. Yeah.
Can I have a follow-up question on that? Do you still find it exciting and interesting? Are you still finding new things to learn?
Yes, it is still very exciting. It is still interesting. Things keep evolving. And then also every time you bring someone new into your team, they will have different ideas. They will have new ideas. And so then that means that our ideas keep growing, our microscopes, we keep getting more creative. So it never ends in the good sense.
We got a question. What is the biggest challenge you face in building one of your microscopes, and how did you solve it?
So most of the time we're solving problems. That's the truth. But again, when you're really trying to push the boundaries, there's a lot of troubleshooting along the way. And so this is very typical. It's something that you get used to it as a scientist, is that things don't work. And that's where that resilience is really important. You get better at troubleshooting, you get better at finding out what the problem is, and again, coming up with solutions. So maybe you expect a result and you're not getting it. Your microscope is just not giving you that. And then sometimes it can be a while until you understand why that's the case. So that is part of our everyday. And it's fine, right? That's when you have to remember, okay, that one time when I was in the mountains and it was like really hard, but then you figured it out and you made it. So it's just a little bit of practice, but it happens every day.
Thank you, Cristina. I have Liliana here asking, what was the hardest obstacle you have to face to get to where you are right now as a scientist?
Yeah, I would say maybe going back to that idea of not having many role models. when I started my journey, because like not having role models, which also meant like, well, I guess at some point if I do want to have a family, then that's not possible. These two things are not compatible. So I think that was the biggest challenge. It was something that kept, in a sense, distracting me and draining my energy when it should have not happened that way. But I didn't have good examples. Fortunately, that is changing, and I do have role models that I can look up to, and they're women. And some of them also have families, so that's different. But for a very long time, I didn't have that, and I do think that was one of the hardest challenges. Of course, there were many challenges from the research side, but I think this was I don't know, very big and always present theme that was in my head.
We did
Thank
have
you.
a question that says, is it hard to study the brain's neurons?
Well, I think that it's not as hard as it used to be, because we keep making improvements in technologies. It's because of scientists and students like you who are interested in science and get into these fields that it's not so hard anymore. But then it depends, right? It depends on then how far you want to push things. So there's always something that's going to be harder, right? There's always going to be either a brain region or a specific problem that's harder. But generally, this is something that has become at least much easier than it used to, 100 years ago. So, or even less. But yes.
Okay, so I have another one from another student from Haiti. She wants to know, what is your favorite thing about your job?
What is my favorite thing? It's all of the people that I get to work with. Interacting with all of the researchers in my lab, and then also the students in my classes. I think that is I think that is one of the most satisfying parts of the job. And when I get to do things like this, really, when I get to talk to young girls who are students and who are interested in science, those are usually the things that make my day.
We have a lot of questions from YouTube, so I'm gonna try to filter a couple of them in. Someone asked if you recommend that college students pursue a PhD right after they finish undergraduate, or do you recommend that they go out and get some job experience first?
Totally up to you. I would say there's truly no right answer. I've seen all of the different combinations work really well. I think for some students, if they're not sure whether they want to do research, sometimes, they want to do something first for a couple of years. Some students, if you get to have a research experience during college, this helps because then, you do get a glimpse of it. And then you can decide whether you want to continue. But any and all options work because they're all giving you some, new perspective, and then you can decide, if you do decide to work for a couple of years, then that's great, and maybe you decide that that's what you want to do. So really no right answer.
And then a question from Mariam on YouTube. If you didn't do the career you're doing now, what would you do?
I used to want to be a medical doctor. I'm not sure that's what I would want to do now, but I feel like in some ways, I kind of went full circle because I'm not close to doing anything close to what a medical doctor would do, but at least it's sort of back to the more life science related with possible impacts into society in that way. So I generally like that. But if I had not studied physics, there's many other careers that would have also been very I think, very powerful for this type of work. Like currently, I'm in a biomedical engineering department, and I think this is a really exciting career. It's a relatively new major, so when I went to college, this didn't really exist, definitely not in my university. But I think it does combine a lot of the things that I was interested on. So perhaps I would decide to major in biomedical engineering.
So I have a really cool question from Carolyn. Sorry, Ayana. She says, when you start an experiment, do you get research first or see if somebody else has done the experiment first and their results?
Really good. Yeah, no, it's a really good question, right? So if you're trying to do something new, it's always good to see what's out there, right? Because you may not necessarily want to do exactly, what other people have done. Maybe you do see what they have done, and maybe you want to first reproduce that because you want to build on it. And then you first have sort of that maybe like a ground truth, like, okay, we're first going to replicate this experiment that other people have done, and this is published, and then you improve upon it. So but yes, we generally we try to stay up to date with the literature and see what others have done.
There was a quick question. Can you take pictures of the lunar eclipse?
Well, you could, not with my microscope, but we can do it with telescopes. And but yes, just even with a telescope that you can, nothing too fancy, you can get pretty good pictures.
Okay, tengo una pregunta en español. I have a question in Spanish from YouTube. We're gonna answer it in Spanish first and then I'll translate. La vamos a contestar en español primero. De Gina en YouTube. ¿Qué desafío fue el más difícil que tuviste en la ciencia?
A ver, ¿cuál fue el desafío más grande? Una de las cosas que mencioné antes fue el no tener role models durante mi carrera. Yo estudié física y al menos en ese entonces yo no tuve ninguna profesora en física. Durante toda mi carrera no tuve ninguna profesora que fuera mujer. Y la verdad es que eso siempre estuvo ahí en mi cabeza como fastidiándome, porque me encantaba la física, pero al mismo tiempo cuando no ves nadie como tú que lo está haciendo, que es profesora, pues eso es muy difícil. Para mí, esa parte fue más difícil que los retos que encontré durante mis estudios o durante el proceso de investigación. A ver, irme también fuera de mi país, por supuesto, fue difícil, pero bueno, eventualmente pues, me acostumbré y, ¿sabes? Uno conoce personas maravillosas pero yo diría que esas cosas quizá un poquito más generales son los que yo considero que fueron los desafíos más grandes para mí durante mi carrera. Ya otras cosas como que el experimento no te funcione, de eso aprendes, eso es la ciencia. Entonces no lo veo tanto como algo negativo de que este experimento particular que no me dio, sino que así es como uno aprende, así es como uno empuja el conocimiento hacia adelante. Giovanna, ¿quieres que lo resuma?
Sí, puedes, si quieres decir la pregunta en inglés y el resumen, that would be great.
Okay, so the question was, what was, I guess, the biggest challenge that I had throughout my career? So I talked a little bit about what I mentioned earlier on not having role models and how, to me, that was sort of a bigger challenge than maybe the everyday challenges that I found during my studies or during my research. I also mentioned that, I left my country to come here, and that was also, very hard at first. And I think for me, those like sort of bigger, I don't know, things sort of were more of a challenge than those everyday, challenges that you find in the experiment, or like you don't do well in a class or in an exam. I think that's, I was saying that at least in research, that's how things are supposed to go. It has to be challenging. If it's not challenging, we're not pushing the boundaries of what we know, right? In order to find cures to diseases, and in order to come up with creative ways of solving problems in the world, it will be challenging by definition. So we just have you get used to it. You get used to that sometimes uncomfortable feeling, but that's how we push science forward. I hope that answers the question. Espero que eso haya respondido a la pregunta.
Let's see. I have a couple of related questions on YouTube that I think maybe tie into this. So, has anybody ever told you that you're not good in science or you shouldn't continue, or what would you say to someone, who has experienced that?
No, it's a very good question. So I never had anyone so directly and bluntly say that. But sometimes, sometimes you still get that feeling, right? Sometimes, even if it's not direct. But I was lucky to not be in that situation. I think that's, of course, very unfortunate and very toxic that someone would say that. I think that, but of course, I've been, I felt that way, right? Because of, again, in direct ways, because sometimes you feel that way and it's normal. But I think that you have to believe in yourself. You have to look back at all of the times when, when you've done great things and when things have worked and when you have felt good about yourself and remember that. And if that's what you want to do, then keep pushing forward, because you will make it, and you will always encounter people that might not be as encouraging. Those that exist, but hopefully, right, that will be counteracted with all of the other people who are supporting you and encouraging you to keep going.
I have another good question. Do you ever repeat experiments you have already done to see if you get different results or for a different reason?
Very good question. Yes, and generally we always repeat experiments, because if we can only get it once the result, then that's not good. So yes, we do repeat experiments many times, and sometimes, yes, for different reasons. Maybe we stop doing that type of work, and then maybe we want to get back to it and build upon it. So then we repeat the experiments and we build upon it. I see a question in Spanish in the chat, Giovanna. I don't know. It says, ¿qué le inspiró a ser científica? I know I answered something, but maybe I can quickly. Okay. Para la pregunta que qué me inspiró a ser científica. Algo que dije antes tuvo que ver con mi mejor amiga, porque ella estaba fascinada por el universo y ella fue la que me arrastró al mundo de la física. Entonces, eso me sirvió de inspiración. Pero mi mamá, que no lo había mencionado, mi mamá es doctora, mi papá también, y la verdad es que esa mente científica estuvo en mi hogar y pues lo vi desde chiquita y yo diría que sí, mi mamá la verdad es que fue una de las científicas que me inspiró y todavía, porque ella pues me ha apoyado durante toda mi carrera. So briefly in English, the question was what inspired me to be a scientist. So I mentioned again my best friend who basically convinced me to study physics. Not convinced me, but then I also mentioned my mother, who's a medical doctor, and so is my father. So I think that being a scientist was something that I really aspired to, and I would say my mom was a big inspiration.
We have one more question here on the chat. How long have you been studying, or how long did you study? Maybe not the best last question, but
sure, we want to end on that note. No, but the thing is, so I did my college years, which in Venezuela was a little longer, but so it was college. And then I did the doctorate, which was it's about the same as college. Let's put it that way, maybe a little bit more. So that's about as long. But the thing is, even when you're pursuing your doctorate, when you're doing a PhD, to me, I didn't see it, yes. At the beginning, you take classes and it feels, yes, and you're a student. But for me, especially, after that first year or two, when you're still taking classes, after that, you're only doing research. And for me, that was a job, because to do a PhD, you actually get paid. You get paid to be a PhD student. It's amazing. Like for me, this was like, wow. So it's a job, and you get to do research and you get to push knowledge forward. So I never saw it as, oh, I'm going to be a student forever. Like, no, I did college and then PhD, but after that first year or so of classes, then it's really just been research, which for me, that's my job. So I hope that ends in a more encouraging note.
Absolutely. Thank you.
Okay.
Well, oh. Well,
Go ahead,
thank you,
Ayana.
everyone. Thank you, everyone, for coming to our lovely webinar series. And everyone, please say thank you to Dr. Rodriguez for coming here and sharing her story and answering all those fun questions for us. Thank you so much for that. And thank you, our attendees for Seeds of Success. We can't wait to share more of the program with you guys. And feel free to also ask these type of questions to the mentors that you have around you. They all have different stories. They all have different experiences, probably some maybe even close as Dr. Rodriguez as well. We all have similar stories. We all have different ones. So definitely keep always constantly asking questions and learning new information. So thank you so much, you guys, for coming.
Thank you, everyone.
Thank you, Caro. Can you stop the recording, the live?